So the tests that we've learned in sections 11.3 and 11.4 have all been for positive series, meaning all the terms are positive. There's no minuses involved. Of course, not all series are like that. In fact, there's a whole lot of series that have this kind of thing happening, where it goes plus minus, plus minus, plus minus. That's very common. That's called an alternating series. So here on the board are two different alternating series. And how do we write this down? Well, this is just 1 over n, but it's got a negative 1. But if I do negative 1 to the n, well, for n equals 1, that would be negative. So you can write n plus 1, or you can write n minus 1. I don't care. Here, again, this looks like n over n plus 1, and then I've got this alternating minus 1 to the n. Okay? So, but typically, they'll give you the formula. You don't have to figure out the formula. So I just wanted you to visualize what this really looks like. Alternating series are nice because it's much easier for them to converge. Why? Because half the terms are being taken away, right? If it's all positive terms, it has to be something, it has to go down quickly in order to converge. But if there's negative terms involved, hey, it's easier for it to converge. So the alternating series test is an easier test because these series, it's easier for them to converge. Okay? So now if you just think about it, what is happening when I do these, right? Let's look at the first one, the alternating harmonic series. Very good, right? So each time I add something and then I subtract something. So if I look at a number line, so here's 1, 0 and 1. Starting from here, here's S1. S2, I've taken away a half, so I'm back here. I added something. So for S3, I'm over here. And now I'm subtracting something. So I'm over here. So I keep going back and forth and back and forth. Okay? Unlike the situation, if these were all positives, I'd just keep adding and adding and adding. And the question would be, like, am I actually approaching something, or am I approaching infinity? I'm like talking out of the frame, I'm sorry. So getting used to the video thing. Okay. So you can see just sort of by thinking about this, you can visualize it here, S2, S3 is going to be here, and it's going to go back and forth and back and forth. Again, I'm not going to do the proof of this in generality on the board. I'll give you a link if you'd like to see it, but it's precisely this that will prove what we need to do, what we need to show, rather, for an alternating series to converge. And basically, you saw, and you can imagine that this alternating harmonic series is going to converge because each time I'm moving less, right? Each term is smaller, I'm moving less, and eventually, actually, those terms go to 0. So somewhere in there, I'm going to come down to some number. And that's really what the alternating series test is. That's exactly what we're going to check. So let's write this up. What they do, by the way, what your book does, and do be careful, especially if you're looking online, not every book uses the same letters and stuff, so it can be confusing. What he likes to do is he's going to write it -1 to the n, bn. So this whole thing is your an term from before, but the bn is strictly positive, so he's breaking off the sign. Okay? So this alternating series then is, okay, or I suppose he wants it as n-1 to be correct. I'm trying to be consistent with the book here because he's going to start with b1 minus b2 plus b3 minus b4, this sort of thing. Okay? But your bn's are strictly positive. Okay? So this is the alternating series. So the alternating series Bn converges if you have two things that you have to show. The first is that the Bn's are decreasing. So Bn plus 1 is less than or equal to Bn for all n. So this is Bn decreasing. And the second thing we have to show is that it's decreasing and it's decreasing to 0. Limit as n goes to infinity of Bn. So there you have it. That's the alternating series test. What I'm going to do is do a couple examples, but I'm going to write it up here so we don't lose it. Just this, Bn plus 1 less than or equal to Bn, and limit goes to 0. Okay, that's what we're going to check. And I'm going to write what this series is. Oh, and by the way, it doesn't matter whether, I mean, it matters for what the terms are, whether it's n-1 or n. But you can use the test regardless of this, whether it's n-1 or n, as long as it's alternating. It doesn't matter whether you start with a -1 or a negative or a positive b1. Okay, so let's look at the two series we have on the board. The first one is the alternating harmonic series. Okay, so our Bn is just 1 over n, and we can check whether it's decreasing. Pretty straightforward. Bn plus 1 is 1 over n plus 1, and just like we did back in the section with direct comparison, we can see that n plus 1 is strictly greater than n. So Bn plus 1, which is 1 over n plus 1, is strictly less than 1 over n, which is Bn. So yes, Bn is decreasing. My first condition, Bn is decreasing. And so for my second condition, I'm going to look at the limit. The limit as n goes to infinity of 1 over n is clearly 0, which is exactly what we want. So my alternating harmonic series converges by the alternating series test, and feel free to just write AST instead of writing out alternating series test, which is becomes quite long to write that out. It's perfectly fine to use that AST. Okay? So, which tells you something interesting about this harmonic series, or maybe it tells you something interesting about alternating series, because it's easier for alternating series to converge. Well, let's look at the other one. What was the other one? The other one was this. Okay, well, what's also nice about the alternating series test is even though your book lists it like this, 1 and 2, both of those conditions have to hold. So if one of the conditions doesn't hold, you don't even have to worry about checking the other one, right? So here, if I look at this, I can see clearly that this Bn, that's n over n plus 1, that guy's going to go to 1. This is not going to 0. This series isn't going to converge. Okay? So I could just look at that. So I can just write that out. Bn is n over n plus 1, and limit as n goes to infinity of n over n plus 1 is equal to 1, not 0. So this series fails AST, and in fact, it diverges. It diverges actually by the, what do you call it? Diverges by the test for divergence, right? Because even with my minus 1 to the n there, that limit does not exist. So it diverges by the test for divergence. So that's that.